Alright, welcome to Algebra 1, Chapter 8 lessons. I'm going to go through this pretty quickly. The idea is that it's going to be a quick review for you to watch before class, then we'll do an in-class lesson, and then if you want to study for the test and you just want to brush up on what we had covered, it'll be a quick way to review then as well. So it's not going to be completely fully in-depth that we'll do in class, but just give an idea of what's expected. Alright, here we go. So 8.0, the first section in this chapter, which is going to be on transforming graphs and functions, is just how to graph a parabola. So we've already spent a lot of time graphing straight lines, and so we're going to learn how to transform straight lines, but we're also going to learn how to transform parabolas, both because that's leading us into quadratic equations in the next chapter, and also because when you're translating a parabola, it's a lot easier to see what's happening because the shape is so distinct. If you transform or translate a linear equation, sometimes it can be confusing what actually happened because it's just a line and there's not much shape or character to it. So the first thing is, what is a parabola? A parabola, our definition for this class is going to be, it's the graph that you get when you graph a function that's a polynomial function and it has an x squared in it. So anything with an x squared in it is going to be a parabola. So our easiest example is going to just be y equals x squared. But you could imagine there could be more complicated examples like y equals 2x squared plus 5, or y equals negative x squared minus 2x plus 1, or anything like that. So as long as it's a polynomial, and as long as it has an x squared in it as its highest power, then its graph will end up being a parabola-shaped graph. And just to give you a heads up, all parabolas are going to have a shape kind of like that. They might be upside down, but they'll all be kind of curvy like this. Okay, so we're going to learn in this section how to graph the shape like this. What exact shape does it have? So to see the general idea, we're going to make a t-table, and we're going to focus in completely and only on y equals x squared. So we'll learn about all these other more complicated parabolas throughout Chapter 8 and into Chapter 9, but for now, we just want to understand how to graph the basic function y equals x squared. So to do that, we're going to make a t-table, and we're going to make our x and our y variable, and we're going to see the relationship between the input and the output. So whatever we put in for x, we're going to square it, and that's how we get our output. So if you put in x equals 0 and you square it, you get 0 squared, which is 0. If you put in a 1 right here for x, 1 times 1, or 1 squared, is 1. If you put in a 2, 2 squared is 4. If you put in a 3, 3 squared is 9. If you put in negative 1, let's think about what happens on the other side. If you put a negative 1, any negative number times itself is going to be positive. So negative 1 squared is just positive 1. Negative 2 squared is positive 4. And negative 3 squared is positive 9. So you're starting to see that on the positive side it goes 1, 4, 9. And on the negative side it goes 1, 4, 9. So that's why, if you imagine there being an axis right here, the positive side, this is positive x, and this is negative x. The positive side and the negative side have the same shape. So we're going to graph this for reals on the next slide. So we had the point 0, 0, if you remember. We had the point 1, 1, and we had the point, so this is 2, 1, 3, 2, comma 4. So this is 4, 1, and then we had 3, comma 9. That's 7, 8, 9. So there's going to be our 9, and there's going to be 8. So I apologize, my graph doesn't quite go all the way up. So you can see, if we do the negative side, negative 1, negative 2, and negative 3, up 9, up 4, and up 1. These are the special points that we get. And typically, on a graph that you're doing, you don't have to go all the way up to 9 because your graph might not be that big. But these first 5 points, 0, 0, 1, 1, negative 1, 1, negative 2, 4, and 2, 4. Those are the critical 5 points that you need to draw or to plot when you're graphing a parabola. And then we're going to connect it with a kind of nice, smooth, curvy line. Sorry, on a mouse it's hard for me to draw a nice, smooth curve. But it generally has this shape. So it's a kind of U-shaped. And the critical thing for any parabola, so later on we're going to learn about moving these parabolas up and down and stretching them and shrinking them and reflecting and doing all kinds of cool stuff. But this basic idea that once you have this starting point, so this starting point right here, it's going to be at the origin. Now if you move it side to side, you move that starting point, but you always start at 0, 0 for the basic parabola. And this point has a special name. It's called the vertex. Okay, and from there, this point right here is over 1, up 1. So you go over 1, and you go up 1. From the vertex to the first point is over 1, up 1. To get to the second point, you go over 2, up 4, because 2 squared is 4. Again, from the vertex. So the key thing here is that to get to the other points, you're always measuring from the vertex. Over 1, up 1, over 2, up 4, over 3, up 9. For example, if you went over 10, you would go up 100, because 10 squared is 100. So it's just an input-output relationship. Whatever your input is, which is on the x-axis, you square it, and that gives you your output on the y-axis. So that's the basic shape of a parabola, and we're going to keep revisiting this over and over and over as we learn kind of how to manipulate it and modify it into more complex shapes and patterns. All right.